Welcome to PreMath. In this video, we have got this triangle ABC along with these perpendiculars CD and EF, as you can see in this diagram. And as a result, we get this angle EBF as X and this angle ACD as Y. And bear in mind that these angles X and Y are between 0 degrees and 90 degrees. And furthermore, this segment CF is equal to this segment FB, whereas this segment AD is equal to this segment ED. And now our task is to solve for X in terms of this angle Y. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. In order to make our job simple, we are going to draw some auxiliary lines. So therefore, I'm going to connect these two vertices C and E. As you can see in this next step, I have connected these 2 points. And now let's focus on this triangle BEC. And we can see that these two right triangles are our congruent triangles. Since these side lengths are congruent, this is our common side. So therefore we conclude that this side length EB is going to be congruent to this side length CE. So therefore this triangle BEC turns out to be our isosceles triangle, since this side length equal to this side length. So therefore we conclude that this angle has got to be congruent to this angle. If this angle is X, then this angle has got to be X as well. And now let's recall the exterior angle theorem. According to this theorem, the exterior angle of a triangle is equal to the sum of two opposite interior angles, as you can see in this given diagram. And here we can see this angle C is our exterior angle, whereas these two opposite interior angles A and B, such that our angle C is going to be equal to angle A plus angle B. And here we can see this is our exterior angle, and that is going to be equal to the sum of these two opposite interior angles. So therefore this angle has got to be 2 times X, since these opposite interior angles are X and X. And here's our next step. Let's focus on this triangle ACE. We can see these two right triangles, this right triangle and this right triangle are congruent triangles, since these side lengths are congruent and this is their common side. So therefore we conclude that this side length CE is going to be congruent to this side length AC. So therefore we conclude that this whole triangle ACE is an isosceles triangle, since this side length equal to this side length. So therefore we conclude that this angle has got to be equal to this angle. If this angle is 2x, this angle is going to be 2x as well. And now let's focus on this right triangle ADC. And now let's recall the triangle sum theorem. According to this theorem, the sum of 3 interior angles in a triangle is always 180 degrees. And here in this triangle ADC, our 3 interior angles are Y, 2x, and this 90 degrees, and they must add up to 180 degrees. So therefore I can write down angle 2x plus angle Y plus 90 degrees must be equal to 180 degrees. And now we are going to move this Y angle and this 90 degrees to the right hand side. So therefore we can write 2x equals to 180 degrees, and this become minus Y minus 90 degrees. And if we combine these like terms, 180 degrees minus 90 degrees is going to give us 90 degrees. So therefore we are ended up with the 2x equals to 90 degrees minus y. And now I'm going to divide by 2 across the board to isolate x. And here we can see 2 and 2 is gone. So therefore our angle x value turns out to be 90 degrees divided by 2 is going to be 45 degrees minus y divided by 2. And this is our solution for x in terms of y. So thus, after all the calculations and manipulations, our angle x turns out to be 45 degrees minus y divided by 2. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.